All right, so 3.5 of velocities. We're going to start with something called linear velocity, and that's just your basic velocity around a circular object. And we measure that by v equals s over t, and well, s hopefully remember from previous sections, and t of course is time. And a more formal, I'll read off what your book says as more formal, but I hope you explain. If P, capital P, is a point on the circle of radius r, and P moves a distance s on the circumference of the circle in an amount of time t, then the linear velocity v of P is given by the formula this. Basically, given an r and a point, you can find what the linear velocity is, along with, of course, time. Let's say, for example, you traveled 12 centimeters over the course of 4 seconds. What is your linear velocity? It would be simply 12 cm over 4 seconds. 12 divided by 4 is 3, so 3 centimeters a second would be how you would write that. Another type of velocity that we will measure is angular velocity. It's still a velocity moving in a circular motion. And this is if we're given theta, an angle, and t time. This right here is, and I know this is me drawing, but this is omega. Okay, I know it looks like a W. Omega kind of looks like a W. I try to give it its similar problems, but that's supposed to be omega. Omega is equal to theta divided by t. Let's say we have a central angle of 45 pi. And that we also have a time of 1.2 hours. Let's find this angular velocity, given this information. So we're going to simply just do 45 pi divided by 1.2 hours. And if you divide those two, you're going to get approximately 118 radians an hour. Or you might write it like, if you did 45 divided by 1.2, you would have got 37.5 pi. Same thing, radians an hour. Okay, so we have a terrible drawing here. This is supposed to be a lighthouse, okay? Lighthouse. And this lighthouse is 100 feet long, or rather 100 feet from a wall, okay? This being the wall, right here. So that's the wall. It's 100 feet from a wall. And there's a light that completes one rotation every 4 seconds. So what I want you to do is, one, find the equation that gives distance d in terms of time. And then we're going to find d when t is equal to 1/2 second and 3/2 seconds. There is a last part to this, but I'm going to hold off. We're going to find the equations first and then go from there. So, that's the angle that's coming out of it. What are we trying to find? We know every one time around is 2 pi, right? And it takes, what do we say, 4 seconds? Yes, we said 4 seconds. So, omega is going to be equal to 2 pi over 4, which simplifies down to pi over 2. And we're trying to find distance d, so what trig function do we need to use in order to find distance d? Well, we're given the opposite and we're given adjacent, so therefore you have to use tangent. Tangent theta is equal to d over 100 feet. So to get an equation for d, it will be just 100 feet times tan theta. Now I'm going to use a different color just to kind of emphasize this. So if we have omega is equal to what's omega equal to? Theta over t, right? And if we move t to the other side, t omega equals theta. And we said earlier that omega is equal to pi over 2, so it'll be pi over 2 t equals theta. So now we can substitute in this pi over 2t in for theta, giving us d equal to 100 tan pi over 2t. Now to solve the question, I'll use green just to kind of mix up the colors a little bit so you know. If we put 1/2 into here, 1/2 right here, and for t, what will we get? So it'll be pi over 2 times 1/2, which is pi over 4. Tan of pi over 4 is equal to 1, and 1 times 100 is 100. So your d will be equal to 100. And then if we put 3 over 2 in, that will simplify to 3 pi over 4, which will get us -1. And then -1 times 100 will just get us -100. So when we put 3 over 2 in, we'll get -100 feet. Now, what happens when t is equal to 1? Well, when t is equal to 1, you get pi over 2 times 1, which is pi over 2. At tan of pi over 2, it's undefined. So why is it undefined? Well, as we move the light 1 second, it will be parallel. So therefore, it will be undefined. To show how linear and angular velocity are related, you use this following formula. Linear and angular don't let me draw. There we go. Velocity, use V equals R times omega. Of course, linear is this one. Omega is your angular velocity. And then R, of course, is our radius. So let's give the example that you're given omega is equal to 4 radians a second. You're given your radius is 2 inches and time is 5 seconds. Let's try to find what s is equal to, which is the distance traveled after time t, right? So this is a two-parter, so we have to use this first. You're given w and r. You have to do this first, and use our formula we started with in the beginning. So when we do that, v is equal to r, which is 2 inches, times omega, which is 4 radian seconds. And when you multiply that together, your linear velocity is going to be 8 inches a second. Okay, and how does that relate to s? Well, we know s is what we're trying to find. S is equal to what? Velocity times time, because remember the formula we wrote in the beginning was linear velocity is equal to s over t, right? So therefore, we have everything else. We don't know what s is, but we know that t is equal to what? What did I give you in the beginning? 5 seconds. And then v is equal to, as we just found out, 8 inches a second. And in order to solve, we multiply together, and we're going to get S is equal to 40 inches. So I was like a two-parter there. We needed to use the linear and angular velocities in order to find what our S was equal to, or distance traveled after time t. All right? I appreciate you watching, and we'll see you in class.